Hello everyone, today's material I'm gonna talk about the material of the probability. But before I start, let me introduce myself. My name is Ruthesia with student ID number is 2113101003 and I'm from Ganesha University. First of all, have you ever think about if you toss a coin, what is the change you'll get ahead? Or if you roll the dice, what is the change you will get 3? Or what change that you will ride in a vehicle? Or maybe you might think like it's gonna be raining today, or it's highly likely that our class will win the school Olympic. Well, in all these events, there is some uncertainty in this randomness because we're not sure of the result, and for this, we use the concept of probability. At first, we have a vocabulary to have an understanding about what we're gonna talking about. First, we have a sample space. Sample space is a list of all possible outcomes. For example, if we flip a coin, either it's gonna show head or a tail. So for one coin, you just get two sample space, which is head and a tail. Second, there is outcome. Outcome is a result of an experiment. For an example, if we flip a coin, in one experiment, you will just get a head. And next is the topic that we're gonna talking about, is probability. Probability is a change that an event will occur, or a measure of uncertainty. Probability have a scale from 0 to 1, where 0 is certainly not going to happen, and number 1 is certainly to happen. And then you could get any decimal in between, so we take a decimal is 0.5, we'll write in the middle, so it's equally likely to happen or not happen. So if the probability is 0.01, it's probably not going to happen, but it could be happen. But if the probability is 0.97, it probably will happen because it's closer to 1, but it might not happen. And there is two types of probabilities that we're going to look at. First, we have theoretical probability. Theoretical probability is basically says what we expect to happen or what should happen. We say that the probability of event E is equal to number of favorable outcomes over sample space. For examples, let's start with a coin. If you toss a coin, what is the change you will get ahead? For the solution, the probability of head is equal to number of favorable outcomes over sample space. Well, we just want to know outcomes of a head, so number of favorable outcomes is 1 over the sample space is 2, which is either is get head or a tail. So the probability of getting head is equal to 1 over 2 or equal to 0.5 or equal to 50%. So 50% chances of getting a head. Next, the second probability type is empirical probability, which is a change that something happening based on our observation of some experiments or what happened in an experiment. For the formula, the probability of event A is equal to a frequency of the event A that occurs over total of frequency. For example, if I flip a coin 500 times and then I end up getting 257 heads, so the probability is equal to frequency of the event A that occurs, which is 257 over the total of frequency is 500. So we got 0.514. So that is the probability of getting 257 hats. And then there is law of large numbers, which is the more trials we do, the closer the empirical probability to the theoretical probability. It means that if I were to do 1000 trials, this will be closer to 50%. And if I will do 1 million trials of a flipping coin, I will get closer to 50%. So, the more trials I do, the more closer the chances to be. Now we move to probability formulas. First, we have complementary condition probability, which is the complement of event A is the event that occurs in the sample space other than A. The complement event is usually expressed as A complement. So, given all the number of events is equal to 1, then the equation is probability of event A plus probability A complement is equal to 1, or probability of A complement is equal to 1 minus probability of A. For example, Anna plays bridge cards, then one card is drawn at random. Determine the probability that Anna takes a card instead of an ace. Well, the sum of all bridge cards is 52 and the sum of all aces is 4. So we just get into the formula. We calculate the probability of K is equal to 4 over 52 and it's equal to 1 over 13. And then we find the probability of K complement is equal to 1 minus probability of K, which is 1 minus 1 over 13. And the result is 12 over 13. So the probability that Anna takes a card that is not an ace is 12 over 13. And next we have condition probability. We write it as probability of B given A. The formula for a conditional probability is probability of B given A is equal to probability of A and B over probability of A. For example, there are 3 blue cards numbered 1, 2, 3 and 4 pink cards numbered 1, 2, 3, 4. And the question is find probability of blue given odd. For the solution, we just get into the formula, which is the probability of blue given odd is equal to probability A and B, which is 2 over 7, over probability of A, which is 4 over 7. And it's equal to a half, and it's equal to 0.5. So it means if I know I've got an odd card, so the probability is 50%. Next is probability addition rules. The addition rule is a method used when 2 or more events occur at the same time. First, we got non-mutually exclusive event. For example, during the selection of the student council president. When choosing the student council president, you want to know if your candidate is both handsome and smart, or just smart but not handsome, or just handsome but not smart. And this event is called non-mutually exclusive event. And the formula is probability of the union of A and B is equal to probability A plus probability B minus probability A intersection B. For example, when taking 52 cards of bridge cards, the probability of getting a black card or A and an ace or B are what? For the solution, We know that the total of the black card is 26 and the total of all the aces is 4. So, we just enter the formula, which is the probability of union A and B is equal to probability A plus probability B minus probability intersection of A and B, which is the result is 7/13. And from the results above, the chances of a black card and aces are 7/13 times. And a card can be a black, an ace, or both. Second, we have mutually exclusive event. Probability of mutually exclusive event are two events that cannot occur at the same time. For concept example, when a coin is tossed once, the head appears. When the coin is tossed again, a tail appears. Each time it is tossed, the coin will always show a different result. The head and the tails cannot appear at the same time. So that is called mutually exclusive event. For the formula is the probability of the union A and B is equal to probability A plus probability B. And last, I got one exercise to help students to practice a probability problems at home. So the exercise is, there are two dice are thrown together. You must to find the probability that the sum of the dice is 4 or 7 that shape. That's all for the probability material that I presented in this presentation. Hope this material can be useful and more understandable. Thank you for the attention and see you next time.